Class 10 Trigonometric identities or Sharma, Chapter 11, Question number 27. It is asked to prove the following trigonometric identities: 1 plus sin theta upon cos theta plus cos theta upon 1 plus sin theta is equal to 2 sec theta. First, you take LCM of both of this, cos theta and 1 plus sin theta. We get here cos theta and 1 plus sin theta. Cos theta divided by cos theta, we get here 1 plus sin theta whole square. And here 1 plus sin theta divided by 1 plus sin theta, we get here cos square theta is equal to 2. Here we can write left hand side. Now we can write it 1 plus sin theta whole square as sin square theta plus 1 plus 2 sin theta and plus cos square theta. And here cos theta and 1 plus sin theta. We can arrange it like sin square theta plus cos square theta plus 1 plus 2 sin theta upon cos theta and 1 plus sin theta. Here we know that sin square theta plus cos square theta is equal to 1. 1 is here, one more, and plus 2 sin theta upon cos theta and 1 plus sin theta. We can write it 2 plus 2 sin theta upon cos theta 1 plus sin theta. If we take common as 2, we get here 2 1 plus 1 sin theta upon cos theta and 1 plus sin theta. 1 plus sin theta divided by 1 plus sin theta, we get here 2 upon cos theta, and we can differentiate it 2 into 1 upon cos theta. 1 plus cos theta is equal to 2 sec theta, which is equal to right hand side. In question number 28, 1 plus sin whole square theta plus 1 minus sin whole square theta upon 2 cos square theta is equal to 1 plus sin square theta upon 1 minus sin square theta. So we know that 1 plus sin square 1 plus sin theta square whole square theta means 1, we can write sin square theta plus 1 plus 2 sin theta, and this we can write sin square theta plus 1 minus 2 sin theta by 2 cos square theta, left hand side. Now arrange sin square theta and sin square theta become 2 sin square theta. Okay, and this 1 plus 1 make 2, so we can write 2 plus 2 sin square theta, and this one divided by this upon 2 cos square theta means we can write 1 minus sin square theta. So here we get 2 plus 2. So we can write here, if we take common here 2, we can write 1 plus sin square theta. And here, if it, we can write 1 minus sin square theta. 2 divided by 2, so we can write 1 plus sin square theta. Here we can write 1 minus sin square theta. So we get here right hand side. Question number 29. 1 plus tan square theta 1 plus upon 1 plus cot square theta is equal to 1 minus tan theta upon 1 minus cot theta whole square is equal to tan square theta. We need to prove separately this two equal to tan square theta and this also to prove to equal to tan square theta. So first we take left hand side, then equal to it to tan square theta, and then right hand side this and let equal to tan square theta. So left hand side it is 1 plus tan square theta. We can write 1 plus tan square theta means 1 plus sin square theta upon cos square theta, and 1 plus cot square theta means 1 plus cos square theta upon sin square theta. If we take LCM of it, we get here cos square theta, and here we get cos square theta and plus sin square theta. And here if we take LCM, we get here sin square theta. 1 is divided by this, so it's multiplied by 1, 2, we get here sin square theta and plus cos square theta. From here we get cos square theta plus sin square theta and sin square theta plus cos square theta. This can be deleted, so it can go to upside and this downside, so we can write here sin square theta by cos square theta because this is deleted to each other, so we get here tan square theta. If we take right hand side means 1 minus tan theta upon 1 minus cot square theta whole square, we can write 1 minus tan square theta 1 plus 1 plus tan square theta minus 2 tan theta, and this we can write 1 minus cot theta cot square theta 1 plus minus 2 cot theta, and we know that 1 plus tan square theta means sec square theta minus 2 tan theta, and 1 plus cot square theta we can write cosec square theta minus 2 cot theta. From here we can write sec square theta, we can write 1 upon cos square theta, and 2 tan theta means 2 upon sin theta upon cos theta. Same like that, cos square theta we can write here 1 minus sin square theta, and 2 cot theta means 2 cos theta upon sin theta. If we take LCM of cos square theta and cos theta, we get here cos square theta. Cos square theta divided by cos square theta, we get here 1 minus 2 sin theta. And if we take LCM of sin square theta and sin theta, we get here sin square theta, and we get here 1 minus sin theta into 2 sin theta. Cos theta is divided by cos theta. We get here 2 cos theta into cos theta. And here if you take sin theta sin square theta divided by sin theta, we get here sin theta. We can write 2 sin theta into cos theta. So in the next step, 1 minus 2 sin theta into cos theta divided by this, and if this go to upside and this go downside, we can write here again sin square theta upon cos square theta, which again equal to tan square theta. Right hand side. And in question number 30, it is asked 1 plus sec theta upon sec theta is equal to sin square theta upon 1 minus cos theta. Proof. So in left hand side, it is 1 plus sec theta. We can write 1 plus sec theta as 1 plus 1 upon cos theta by sec theta, again 1 upon cos theta. If you take LCM of this, so we get here cos theta and plus 1 by 1 upon cos theta. We can arrange it as 1 plus cos theta by cos theta, and this 1 upon cos theta. So this is divided by this, so we get here 1 plus cos theta, and if we rationalize it and multiply it with the opposite of this, opposite of numerator, we should multiply it 1 minus cos theta with the denominator and 1 minus cos theta with numerator. So we get here 1 minus cos square theta, and here 1 minus cos theta. This become 1 minus cos square theta means sin square theta, and this 1 minus cos theta, which is equal to right hand side. So it is hence proved. And in question number 31, it is written tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta equal to 1 plus tan theta plus cot theta. So we first take the left hand side, hence tan theta upon 1 minus cot theta plus cot theta 1 minus tan theta. We can write in place of tan theta and 1 minus cot theta upon what will 1 upon tan theta, again same like that, and plus cot theta, we can write cot theta and 1 minus tan theta, same 1 minus tan theta. If we take LCM of this 1 and tan theta, so we get here tan theta, and here we get tan theta minus 1, tan theta minus 1, and plus cot theta and 1 minus tan theta. This go to upside, so it become tan square theta and tan theta minus 1, and plus cot theta 1 minus tan theta. We can change denominator same, so that we should change its sign, so it become same tan theta minus 1. So now we can write as tan square theta minus cot theta upon tan theta minus 1 because their denominator is same. So now we can interchange it again, like tan square theta minus 1 upon tan theta minus 1. So we can, yeah, and if we take LCM of sides, we get here tan theta and tan cube by tan theta minus 1. Now it will become tan theta, tan cube theta minus 1 by tan theta and tan theta minus 1. Now it is the identity of, it is same like identity of aq minus bq, which is a square, which is a minus b, a square plus b square plus ab. So we can write in place of this tan theta minus 1 tan square theta plus 1 plus tan theta, and we can write it again same like that, tan theta minus 1. Now this divided by this, so we get here tan square theta plus 1 plus tan theta by tan theta, and we can change it tan square theta by tan theta because denominator is same for all, 1 plus tan theta plus tan theta by tan theta. So we get here tan theta, 1 upon tan theta means cot theta, and this become 1. So it is same like right hand side, 1 plus tan theta, we can interchange plus cot theta equal to right hand side. In question number 32, sec 6 theta equal to tan 6 theta plus 3 tan square theta sec square theta plus 1. If we interchange tan 6 theta right hand side to left hand side, it becomes sec 6 theta minus tan 6 theta equal to 3 tan square theta into sec square theta plus 1. And we know the property of aq minus bq, this is a minus b, a square plus b square plus ab, so that we can interchange this equation same like this identity. You can write sec square theta cube minus tan square theta cube as sec square theta minus tan square theta and sec square theta whole square plus tan square theta whole square plus sec square theta into tan square theta. So we know that sec square theta minus tan square theta is equal to 1. So we can write 1, and here sec 4 theta plus tan 4 theta plus sec square theta into tan square theta. Now we can write it again, sec square theta whole square plus tan square theta whole square plus sec square theta into tan square theta. And if we need to bring this number 3 tan square theta plus sec into sec square theta plus 1. So if we subtract 2 sec square theta into tan square theta and add also, so we get here minus 2 sec square. We can write sec square theta into tan square theta and plus 2 sec square theta into tan square theta. So this number, this and this make become a identity of a minus b whole square. We can write here sec square theta minus tan square theta whole square, and 2 plus 1 means 3. 3 sec square theta into tan square theta. Now we know that sec square theta minus tan square theta whole square means 1. We can write 1 plus 3 sec square theta into tan square theta, which is equal to right hand side. Hence it is proved. Same like question number 22, it is asked cosec 6 theta is equal to cot 6 theta plus 3 cot square theta into cosec square theta plus 1. We should change and transfer cosec and cot 6 theta into left hand side, so it become equal to 3 cot square theta into cosec square theta plus 1. Same like that, it is identity of a minus b whole cube. We can write a minus b a square plus b square plus ab. So in place of this we can write cosec square theta minus cot square theta, and here we can write cosec square theta whole square plus cot square theta whole square plus cosec square theta cosec square theta into cot square theta. This become 1 and this become cosec square theta cosec 4 theta plus cot 4 theta, and this become cosec square theta into cot square theta. So if this equation cosec square theta we can write again plus cot square theta. If we add and subtract minus 2 cosec square theta into cot square theta, and one time write this 2 also cosec square theta into cot square theta. So this become equal to cosec square theta minus cot square theta whole square, and this become this, and this become 3 cosec square theta into cot square theta. The value of this will 1 plus remaining 3 cosec square theta into cot square theta, which will equal to right hand side. In question number 34, it is asked 1 plus 10 square theta into cot theta upon cosec square theta is equal to tan theta. In place of 1 10 square theta, we can write what? Sec square theta. And in place of cos theta, we can write cos theta upon sin theta. And in place of cosec theta, we can write 1 upon sin square theta. And further, we can change sec square theta as 1 upon cos square theta, and into cos theta upon sin theta by 1 upon sin square theta. We can write this again as, because cos theta divided by cos square theta, you can change 1 upon cos theta into cos theta, and this cos theta upon sin theta by 1 upon sin theta into sin theta. 1 cos theta divided by cos theta, so it become 1 upon cos theta into sin theta, and this become 1 upon cos theta into sin theta. 1 upon sin square theta, sorry, 1 upon sin square theta means sin theta into sin theta. So we can write it go to upside, and this is downside, so it becomes sin theta into sin theta upon cos theta into sin theta. Sin theta divided by sin theta, so it becomes sin theta upon cos theta. This will equal to tan theta, which is equal to right hand side. In question number 35, 1 plus cos a upon sin square a upon 1 minus 1 upon 1 minus cos a. Simply in left hand side 1 plus cos a, we can write 1 plus cos a, and in place of sin square a, we can write 1 minus cos square a, means 1 plus cos a and 1 minus cos a, and we can write again 1 plus cos a. This will diluted, and we get right hand side option. Question number 36. Question number 36. It is then sec a minus tan a, sec a plus tan a is equal to cos square a upon 1 plus sin square a. sec a minus 10a, sec a plus 10. Simply we rationalize it by multiplying the opposite of denominator, means sec a minus 10a, sec a minus 10a. It becomes sec square a, sec a minus 10a whole square, and this becomes sec square a minus 10 square a. So it become, because the value of sec square is minus 10 square is equal to 1, so we can write simply sec a minus 10a whole square. In place of sec a, we can write 1 upon cos a, and in place of 10a, we can write sin a upon cos a whole square. By taking, if we take the LCM, so we get here 1 minus sin a whole square, 1 minus sin a whole square. So we can write here 1 minus sin a whole square upon cos square a. Further, we can write 1 minus sin square a upon 1 minus 1 minus sin whole square upon 1 minus sin square a. We can write 1 minus sin a in place of sin a whole square. We can write 1 minus sin a into once again 1 minus sin a, and 1 minus sin square a, we can write 1 minus sin a and 1 plus sin a. 1 minus sin a divided by 1 minus sin a, so we get here 1 minus sin a and 1 plus sin a. If we further multiply it, 1 plus sin a and 1 plus sin a, we get here 1 minus sin square a and 1 plus sin a whole square, 1 minus sin square a whole square, 1 minus sin square a. So we can write 1 minus sin square a as cos square a and 1 plus 1 plus sin square a, 1 plus sin whole square, which is equal to right hand side. In this question number 37, 1 plus cos a upon sin a is equal to sin a upon 1 minus cos a. Simply we can write, take left hand side 1 plus cos a upon sin a and multiply by it opposite of numerator, means 1 minus cos a and 1 minus cos a. So it become 1 minus cos square a and sin a and 1 minus cos a. We can write. We know that 1 minus cos square a means sin square a and sin a 1 minus cos a. Sin square we can write sin a into sin a and sin a 1 minus cos a, sin divided by sin a is equal to sin a 1 minus cos a, which is equal to right hand side plus.